Hi! Welcome to the second part of our lecture on volumes. In this video, we will talk about volumes of solids by slicing. If you haven't seen the first video, please watch it first. What is the difference between this topic and the one we had before? Before, we had solids of revolution, and we used the method of disks or washers to find their volumes. This time, our solids will be arbitrary, meaning they don't need to be solids of revolution. To find the volume of an arbitrary solid, we will use the method of slicing, which is actually a generalization of the method of disks and washers. Now let's begin. We first define a cylinder. A cylinder is formed by two congruent parallel plane regions B1 and B2, the top and the bottom, and a lateral surface, or the sides. If the lateral surface, or the sides, is perpendicular to B1 and B2, just like in the figure that we have here, then the cylinder is called a right cylinder. An example of a right cylinder is a disk. In fact, a disk is a right circular cylinder where the top and bottom are circles, and the lateral surface makes a right angle with the top and bottom. The volume of a cylinder is area of cross-section times height. By cross-section, we mean B1 or B2. So volume of a cylinder is just area of B1 times height. For example, for the disk, the volume is area of circle times height. So it is just pi r squared times height. Remember, for this topic, our solid doesn't need to be obtained using revolution about some axis. It can have an arbitrary shape. So, consider the following solid S, which looks like a bread loaf. S is bounded by two planes perpendicular to the x-axis at x equals A and x equals B. Consider this red cross-section here at an arbitrary x between A and B. This cross-section is in the plane perpendicular to the x-axis, and the area of the cross-section is given by a continuous function a of x. Our question now is, what is the volume of the solid S? To answer this, we use the method of slicing. This method is very similar to the method of disks and washers. Remember that story? If not, watch the first video. Anyway, we follow the same story here. The only difference is, before, when we slice the solid, we get disks or washers. But now, when we slice the solid, what we get is a cylinder. Remember, a cylinder can have arbitrary shape for its base, or the top and bottom. So now, we are in the more general case. Let us review the story. First, we divide the interval AB into n subintervals of equal length delta x. So all of these have lengths delta x. Then we choose an arbitrary point xi star in the ith subinterval. So remember, each subinterval here will correspond to a cylinder. And this time, it's a cylinder instead of a disk or a washer. The volume of the ith cylinder is just area of the cross-section at xi star multiplied by the thickness of the cylinder, which is delta x. So, to to get an approximate for the volume of the solid, what we do is add the volumes of all the cylinders. Like so. And to make the approximate better, we make the number of cylinders bigger and bigger, while making the thickness of the cylinders thinner and thinner. So, if we let n go to infinity, we get infinitely many very, very thin cylinders, and we get the actual volume of the solid. Mathematically, we write it this way: let n go to infinity to get the volume of the solid. And thus, the volume of the solid is given by the definite integral of a of x dx from a to b, where AB is the interval covered by the solid in the axis that we sliced. So AB here is the interval covered by the solid in the axis that we sliced, in this case, the x-axis. Again, if we slice the y-axis instead, then we will get delta y, meaning in the integral, we will just get dy a of y, and the interval must be in the y-axis as well. So, here is the general formula of the volume of a solid by slicing. V is a definite integral from a to b of a dw, where AB is the interval covered by the region, A is the area of a cross-section at an arbitrary point in the interval I, and dw is dx if the solid is sliced vertically, or dw is dy if the solid is sliced horizontally. Here are some notes. If A equals pi r squared, for example, then the cross-section will become a circle, and thus the cylinder we obtain is a disk. Thus, we will have the formula in the method of disks. Or if A is this one, pi r2 squared minus r1 squared, then the cylinder we obtain is a washer. And thus, we have the formula in the method of washers here. Thus, we can say that the method of disks or washers, they are just special cases of the method of slicing. Next, slicing vertically means we are slicing the x-axis, or in other words, the cross-sections are perpendicular to the x-axis. So likewise, for slicing horizontally, that means that we are slicing the y-axis, or in other words, the cross-sections are perpendicular to the y-axis. Let us now have some examples. First question for this one, so we want to find the volume of the solid shown below. Notice that we are already given the figure for the solid. And it says here that each cross-section is a circle. So this is a circle. So what do we ask first? We want to know if are we going to slice the solid vertically or horizontally? Or in other words, do you slice the x or the y-axis? So notice that the cross-sections are circles, and they are perpendicular to what axis? It is the x-axis. So that means we should be slicing the x-axis. And since we are slicing the x-axis, or we are slicing vertically, then that means we choose the variable x. Thus, everything else in the integral must also be in the variable x. For example, the interval must be in x. So, interval is in x-axis, meaning we start from x equals 0 until x equals 1. That is the interval covered by the region. Next, what is the area of the cross-section A of x? Since the cross-section is a circle, okay, so this is the interval, okay, so our next question is area of the cross-section. So since the cross-section is a circle, area of circle is pi r squared. So our question is, what is your radius r? Okay. So if you notice, for this cross-section, this circle, it's hard to find the center of the circle. So if you remember, radius is from circle to the from center of the circle to the to a point on the circle. So it's hard to find the center. So instead of doing that, we can just compute the radius as half of the diameter, because the diameter is easier to find. The diameter is just this distance, which is a vertical distance. It's from this point to this point. Okay, so that means we will just subtract the y-coordinates of these points. But here, the y-coordinate of this point is 2 square root of x, while here you have square root of x. So that will be the diameter, and the radius will just be half of the diameter, meaning the radius will just be the diameter divided by 2, or that is just square root of x over 2. So now, we have the radius. And thus, the area of the cross-section is just area of circle, so it's pi r squared. So plugging that into our formula, we will have pi r squared is just pi x over 4. And thus, formula for the volume by slicing is just integral of your area of cross-section times thickness of cross-section is what it is, dx. So you have integral from 0 to 1, this is interval in x-axis, area pi x over 4 times dx, the thickness of the cylinder. So, if you solve for this definite integral, you'll be able to find the volume. So that's easy, just anti-differentiate and evaluate, and you get this final answer. So let's move on to a more challenging problem. In this case, the picture of the solid is not given, so it's up to you to imagine the solid. Let's read the problem carefully. It says here that the base of the solid is the region in the first quadrant bounded by the graph of y equals 1 minus x squared over 4 and the coordinate axis. Do you know the graph of this function? So, we know that this is a parabola opening downwards and it passes through. So, can you give me some points? So, one point is 0, 1. When x is 0, y is 1. And another point is, so let's say when x is 2, y is 0. So you have 0, 1 and 2, 0. Okay, next. Let's talk about the cross sections of the solid. Okay, here it says that the cross sections perpendicular to the x-axis are squares. So this means that if we slice the x-axis, the shapes, okay, slice the x-axis, the shapes of the cross sections we get are squares. So what does it look like? Can you try to imagine it? So it looks something like this. Can you see the solid now? Okay, so if you connect the dots, then you'll see the solid. And here it is. So now that we have the picture of our solid, let us try to use the formula for slicing to get the volume of the solid. So, do you remember the formula? Formula is integral of area of cross section dw from A to B. So first question is, what variable do we use, x or y? So the clue here is, to what axis are the cross sections perpendicular to? So they are perpendicular to the x-axis. So since we are slicing the x-axis, we must use the variable x. Next, what is the interval in the x-axis covered by the region? Okay, to answer this, it will be helpful to draw the base of the solid, which is said to be in the first quadrant. So this one. So let's draw that like this. So here is the drawing of the base of the solid together with the important points. So remember this point and that point, these are 0, 1, and 2, 0. And now we see that the interval covered by the solid, so you can still see the solid, right? So if you draw squares here, then the solid is somewhere here, right? Okay. So the interval covered by the solid, okay, in the x-axis, okay, because we're using the variable x, is from x equals 0 until x equals 2. Okay, so the last ingredient is the area of the cross sections. Okay, so since the cross sections are squares, the area of square is just side square. So we just need to find where is the side of the square. But we know that the squares are somewhere here, right? So like this, like this. So for example, this broken line here, okay, is one side of a square. Okay, a square cross section. Okay, so that means it's enough to get the measurement of this vertical distance, and then let's square it later. And that's how you get the area of the cross section. So what is this vertical distance? So remember, this vertical distance should be a function of x. So here, vertical distance is y up minus y down. So the y coordinate above is given by this 1 minus x squared over 4, and y down, y coordinate below is y equals 0. So therefore, we will get, okay, so this broken line has length 1 minus x squared over 4 minus 0, or just 1 minus x squared over 4. Thus, the area of the square will just be side square. So just square this length. Okay? And notice that the area is a function of x. So if we put all of these information together, we can now set up the volume of the solid. Volume of solid is integral from x equals 0 to x equals 2 of side square dx, okay, where the side is given by this. And to find the volume, just solve the definite integral, antidifferentiate, first expand, and then antidifferentiate, and then evaluate, and you get this answer. Okay? And that is the volume of the solid by slicing. So let's go to our last problem, and this one is the most challenging of them all. So here we want to show that the volume of a square pyramid with height h and base of side length s is given by 1/3 s square h cubic units. Basically, we want to prove the formula for the volume of a square pyramid. In this case, we definitely need to draw our own diagram. So, what does a square pyramid look like? It's a pyramid with a square base. So here, we note that each cross-section parallel to the base is also a square. Okay? So here, this cross-section, if we slice horizontally, this is parallel to the base, and they are all squares. Okay? So what is the next thing we need? Notice that even though we already have a diagram, it is still incomplete. Why? Because we haven't placed it yet in the Cartesian plane. So how do we do that? To help us, let us draw this blue triangle here. This blue triangle divides the pyramid into two congruent parts. the front part and the back part. Okay? And the blue triangle is perpendicular to the parallel squares. We will use this triangle to set our Cartesian plane. So we set the x and y axis in the same plane as the triangle, like this. Okay? So here is the y-axis, and here in the center here, the x-axis. Here. Okay. So here the x-axis is a perpendicular bisector of the triangle. So meaning it's perpendicular to this side, and it bisects this side as well. So let's take a closer look at this triangle. Here is a triangle in the xy plane. So what we did is just remove the squares perpendicular to this triangle, right? So you can take a look at this, okay? So, right, if you just focus on the blue triangle and remove the pyramid itself and the squares that are perpendicular to the triangle, then you will be left with this one. So just imagine that we rotated this figure counterclockwise by around 90 degrees to get this figure. So nakahiga na siya, right? Okay, so if you imagine the pyramid, this is the top of the pyramid, and this part, nandito yung base ng pyramid from before, okay? Alright, so again, the cross sections perpendicular to the triangle are squares. So imagine the squares cutting the triangle here perpendicular to the x-axis, okay? So it's that drawing is kind of similar to the second example we had before, okay? And di ba may mga squares din doon, tas ang kinakat niya yung x-axis din, okay? So perpendicular yung squares sa x-axis. So question now is, what variable are we going to use? So since we are slicing the x-axis, because remember the squares are perpendicular to the x-axis, then that means we use the variable x. Next, we need to know the interval. So that means we need to know what these points are, okay? So of course, this is the origin. So the question now is, what is this point, okay? So to know that, let's look at the given. So the pyramid has height h and base of side length s. Then imagine the pyramid in this triangle. Diba nakahiga yung pyramid ngayon? So ibig sabihin, this is the top of the pyramid, while here, nandito yung base of the pyramid or the bottom of the pyramid. So that means the height of the pyramid is this distance, and it's given by h. Okay? So this is of length h. Meanwhile, side length is s. So, diba remember, this is the bottom of the pyramid. And from our picture kanina here, this length, okay, is just the same as the side length s. Okay? So that means this length here is just of length s. Okay? So, therefore, what is the coordinate of this point? Okay? So remember, if this is s, then half of that will be s over 2. Then that means you have h s over 2 as the coordinates of your point here. Okay? Okay. So, what is the interval covered by our solid in the x-axis? It will be from x equals 0 until x equals h. So now we have the interval. Next, we need to know the area of the cross sections. Okay? So again, since we are using the variable x, we have to set up the area of the cross section as a function of x. So it must be a of x. So do you remember the shape of the cross sections? they are squares, right? So we have squares here, okay? So as we slice the x-axis, the shape of the cross sections are squares, and the area of a square is side square. So all we need to do is find the measurement of the side. But this broken line is again a side of the square, okay? So we just need to find how long this is. So if this point is a point xy on this line, then what is the length of this broken line? So half of the broken line from here until the x-axis will just be what length? It will be length y, okay? So meaning twice of that will be 2y. So that means a side of the square will have length 2y. Okay? So next, is that enough? Not yet, because we need the area to be a function of x. So we have to write y in terms of x. So to do that, notice that the point xy lies on this line. Okay? This line slanting towards the right. So what we need to do is find the equation of this line so that we can write y in terms of x. Okay? So how to find the equation of a line? So it's easy. All we need to do is either use the point slope form or the point intercept form of the line. So first, to get the slope, we need 2 points on the line, but we already have 0, 0 and hs over 2. So the slope will just be s over 2h. Next, using the point 0, 0, we know that the y-intercept is 0, so using y equals mx plus b with slope s over 2h, then the equation of the line is just y equals s over 2hx. Or, another way to find the equation of the line is using similar triangles. Okay? So by similar triangles, this triangle here is similar to this bigger triangle here. Right? So we can have the relationship y over x is equal to s over 2 divided by h. And from here, we can solve y in terms of x to get the equation of the line. So we get exactly the same thing as the point slope form or the point intercept form that we did earlier. Okay? So we can now write the area of the cross section as a function of x. Because remember, this is one side of the square. This is the square cross section. So the area of the cross section is just area of square, which is side square. So 2y squared, but y you can write in this way. So let's write all of that in terms of x. So area is 2y squared. In terms of x, you get this. And if you simplify, you get this. Okay? Now, I think we're ready to write the volume as a definite integral. So we have volume is from x equals 0 until x equals h. And here's the area of the cross section in terms of x. And then times the thickness of your cylinder, which is dx. Okay? And now we can just integrate and evaluate. And we will get 1/3 s squared h over 3, which is exactly what we want to show. Okay? And that ends this example. We have already proved the formula for the volume of a square pyramid. It's cool, right? Okay. And that's it. Here are some exercises you can try for yourself. This is about volumes by washers. And this as well is volumes by washers. So these are solids of revolution. But for the last one, this is an exercise for volumes by slicing. So just make sure that you make the diagram and follow the steps that we did in our examples here in this video. And that's it. Hope you enjoyed this video. And stay safe, stay healthy. Bye!